Hello and welcome to this short course. We have all used large language models and are impressed by their powers. But how do you get these large language models respond to queries on your own personal documents? Or how do you even get these language models to respond in data they were not trained on? For example, recent events. My name is Altaf Rahmani, and in this short course, I'm going to teach you a technique called Retrieval Augmented Generation, or RAG, which will teach you how to overcome some of these challenges with large language models. By going through this course or by learning RAG, you will be able to look at your own private documents or look at data from other sources like the internet or your databases and do the following. You'll be able to write question answering applications, which means you can do semantic searches, or you can ask questions on your own private documents. You can write dialogue systems. You can summarize documents which are your own. You can generate content or reshape content in a different shape and format from your own documents. And you can also create knowledge-intensive tasks. So let's dive in. In this course, we're going to go over the big idea first. What is Retrieval Augmented Generation? Then look at the definition. Go over why do we need RAG? Overview of the RAG architecture and then how it works. Quickly touch upon some benefits, limitations, and end up with the demo. Okay, so what's the big idea? The big idea is, if you ask, for example, a large language model a question which is very recent, then I'm sure we all have experienced this kind of an answer where it doesn't have the real-time information because of the limitations of the training data it was trained on. But what if you could take the question or your prompt and then provide it the answer or the context? You would have to retrieve the context from some external source outside the large language model and provide both the prompt as well as the context. And then the large language model would be able to provide you with an appropriate answer by referring to the context that you just provided. So that's the big idea behind Retrieval Augmented Generation, or RAG. Let's look at the formal definition of RAG. Retrieval Augmented Generation is an architecture that augments the capabilities of a large language model by adding an information retrieval system. Some people also call it a prompting technique, but let's look at this prompting technique and the architecture in details in the subsequent slides. But first, why do we need RAG? We know that large language models are limited to the information they are trained on, which means they can only answer questions based on the data they were trained on. They're expensive to pre-train or fine-tune, because both pre-training is an expensive proposition. Fine-tuning also means that you'll have to collect data, clean data, fine-tune the model, and then host the new instance of the model somewhere else. And we all know that large language models also have limited context lengths. So Retrieval Augmented Generation, or RAG, allows us to get over some of these limitations. Let's look at the overall architecture of RAG. Step number one, you have to create an external retrieval system, as we said, which means getting all your data into a special kind of database called as vector database. That's the data ingestion step. Second step is querying the vector database. As soon as you get a query or a prompt from the user, you retrieve these similar documents, or you retrieve the matching answers from your vector database. And finally, you pass both the query and the matching documents to the LLM for the LLM to formulate a cohesive response. Let's look at each one of these steps in details. In step number one, you take your data sources. You could take multiple data sources, split them into chunks. And this is a really important part, also called as pre-processing your data. You might have lots of documents. You might have a PDF. You might have a PowerPoint presentation or a text file. You extract text out of all these documents, convert them into chunks, and then you convert these text chunks into embeddings. You use an embedding model to generate the embeddings, and you store the embeddings into the vector database. That is your step one. Then, once you get a user query, you can embed the user query and then match it in your vector database to get the answers or to get the similar vectors from your vector database. This is the key retrieval step. This happens outside of the large language model. And once you get the response, then step number three, you pass the prompt or the query along with the retrieved similar documents, embeddings from your vector database, and that is what you give to the large language model, which then returns a cohesive response which you can send back to the user. So step three is your generation step. Now, the benefits are you can improve your factual accuracy and consistency with this. So this also avoids the hallucination problem that we have with large language models. You can really ground the language model to only return answers from your data sources. It's more coherent and relevant generated text. You can respond to queries from large documents, and you can also incorporate different kinds of knowledge sources in your responses. Let's look at a quick demo. So before we watch the actual demo, let me take you through the pseudocode step by step. We'll be using Llama Index in this particular example to do Retrieval Augmented Generation. And as you can see here, I've used the Llama Index library. I've imported a couple of modules, the vector store index and the directory reader. So the first step is reading your directory where your data resides, which is a simple function call. And it's basically loading all the data in this directory called data into what we call as the documents collection. And then to this document collection, we call another function called from documents, which is in this vector store index. We pass it the collection of documents, and it creates an index over which you can now do the queries. This index then has a query engine object which you can extract, and you can simply send all your inputs to this query engine object, and this query engine object will respond with the answers. So let's see a quick demonstration. Here is the code in this simple Python file, the code which I just showed you, and we have gone into a loop where we are querying, asking the query engine with the question that the user inputs. So let me just show you the demo. So this code actually ingests the data first, and then it allows you to do the query. In all practical terms, you can separate out these two processes. The data is nothing but a simple file called agents. Now I can ask it a question, what are agents? And it will look into the document and provide me the answer from the document. So this answer is coming from the PDF document. Similarly, I can say what are the applications of agents, and it gives a nice answer from the document itself. So this is how you can do simple retrieval augmented generation. Finally, some practical considerations and limitations. You can retrieve information from large documents using this technique. Especially, there are some challenges when the same information appears in multiple places, in which information retrieval can be complex. Similarly, there can be a limitation when it comes to comparing and analyzing complex queries from documents. So there are some practical considerations and limitations that you should have in mind. This is an evolving area of research, and there are lots of techniques to improve on this basic RAG technique that I've shown you as an example. All right, we're at the end of the course. Let me just quickly summarize. Retrieval Augmented Generation, or RAG, combines retrieval systems with generation. They utilize vector databases and connect them with LLMs. LangChain and Llama Index are two of the open source frameworks. There are other frameworks out there. There are multiple advanced RAG techniques like FLAIR, CRAG, MOE or mixture of experts, and RAG Fusion. I've attached a link to all the latest RSI papers on this particular technique. That's it for the course. I hope you found this course useful, and you'll be able to apply retrieval augmented generation in your next project. Thank you.